So I will explain to you how to find the inverse of K1 by using this formula, 1 over the determinant of matrix multiply with the adjoint of the matrix. So firstly, I will do the sign pattern that start with positive and negative. So it will be like this, positive, negative, negative for the first column and the next column and row. So it will be like this. I can choose any row or column in the matrix to find the determinant. So I choose the first row of the matrix. So it will be 3, and the minor of the matrix will be 5, 3, 1, 1, 2, 1, and 2, 2, 5. And for the negative 1, 2, 3, 1, 1, 2, 1, 4, 2, 5. And positive 4, 2, 5, 1, 1, 1, 1, and 4, 2, 5. And for the negative 3, 2, 5, 3, 1, 1, 2, and 4, 2, 2. Why it will be like this? Because if I choose this number, so it will eliminate the first row and the first column of the matrix. And same goes to the negative 1. I will eliminate this and also this. And same for the fourth one, I will eliminate this and also this. And the last one, I will eliminate the 3, and the row for 3, and the column for 3. So after that, I will do the 2 times 2 matrix by move out the 5 in the minor of the matrix here. So it will be like this, 5, 2, 5, 2, 1, 2, 5. So to multiply it, I will use the formula of 2 times 2 matrix. For the inverse of 2 times 2 matrix, it will be AD minus with BC. So it will get like this, 10 minus 2, and multiply with 5, and also same goes to this one. And I will get the 87, negative 7, negative 4, and negative 60 for the rest. And after that, I will add all this number to get the answer for determinant of matrix. So it will be like this, 87 minus 7 minus 4 minus 60, and the answer is 16. So next, I will find the cofactor of the K1. So I will do the same as to find the determinant, but I'll do for all the row and columns for the sign pattern, which is positive, negative, positive, negative, negative, positive, negative, positive, positive, negative, positive, negative, negative, positive, negative, positive. And I will move out the minor for the matrix, which is if I choose this one, the first row and the first column, it will be 5, 3, 1, 1, 2, 1, 2, 2, 5 by eliminating the row and columns. So same goes to the next of the numbers in the matrix. So after that, I move out the number, the first row of the minor in this matrix. So for the first one, I will move out the number of 5, and it will be 2, 1, 2, 5. Then I will multiply it by using the formula of inverse matrix, 2 times 2 inverse matrix, which is 2, 1, 2, 5. It will be AD minus BC, and you will get the answer like this, 29. And I will do the same for the next of the minor, and I will get negative 7, negative 1, negative 20, 10, 2, negative 2, negative 8, negative 67, 9, 15, 45, negative 12, 2, negative 2, 8. Yep. So I transfer it into the matrix form. So it will be like this. And then I transpose the cofactor to be like this by changing the row of the matrix to be in the column. So it will be the first row will be the first column, the second row will be the second column, the third row will be the third column, and finally the fourth row will be the fourth column. And after that, we know the formula, 1 over determinant multiplied with the adjoint of the matrix. So it will become like this. I divide the adjoint of the matrix with the determinant of the matrix, and I got the answer. And finally, I simplify it into this form. And this is the final answer for the inverse of K1.
Explain about the product of P and the inverse of K1. So to get the product, the first row and the first column, we need to multiply the first row of P and the first column of the inverse of K1. Then we'll get the first position. And to get the second position in the row, we need to multiply the first row of P and the second column of inverse of K1. And to get the third column of the row in the first row, we need to multiply the first row of P and the third inverse of K1. And same goes to the fourth column of the answer in the first row. We have to multiply the first row of P and the fourth column of the inverse of K1. So this will be repeated with the other rows, and we'll get this answer where we get all of the answers in fractions. Therefore, by using the coding method, we could not determine the code, and that is why K1 is the wrong answer for this method. Now I will explain how to find inverse of K2 using Arrow method. So first of all, we have to make use of 3 operations, which is multiply a row by a non-zero scalar, or interchange any 2 rows, or replace a row by the sum of itself, or multiply of another row. So to begin with Arrow method, we have to begin with augmented matrix, where the identity matrix is on the right and the K2 is on the left. So we have to proceed with the Arrow operations until the identity matrix appear on the left of the vertical line. So as you can see here, we can only perform the Arrow operations up to a certain point, until here. As the determinant is 0 and inverse does not exist, so we cannot multiply the inverse of K2 with P to get the code. the hidden code. So today I will be explaining how to get the inverse of K3, the matrices K3. So firstly, bear in mind that the matrix is a 4 by 4 matrix, and to find the inverse of this matrix, we use this formula. Okay, 1 over the determinant of this matrix times the adjoint. So please note that this is the basic symbol that we use, and in this particular formula, we'll be substituting A with K3. So firstly, we will be picking one row and one column. So for this case, I will pick one row, 3, 5, 5, 2, 3, 5, 5, 2. And bear in mind that there are negative signs and positive signs. So the formula is that we must put this addition and subtraction formulas or signs alternately to the right and also to the bottom. So you must apply it throughout the whole 4 by 4 matrices. Okay, hence the negative 5 and negative 2 number. Therefore, when we find all the minors, after splitting them by using 3 by 3 matrices, we'll continue with multiplying the minors and subtracting it using the basic formula AD minus BC. So this should be it, AD minus BC. So hence you got 3 bracket 2 minus 12. And you must apply it for all the other formulas, for all the other workings as well, for all the other numbers. So this will be the products, 0, 1 to 5, negative 75 and negative 30. So what you do with these numbers is that you actually add them. And when you add them, then you will actually find your determinant. So hence the determinant for K3 is actually 20.
So in the step 2, I will be doing what I did in step 1, which is multiplying by the minors, but instead of doing for only one row, which is 4 numbers, I will be doing for all rows and columns, which by total I should have 16 3 times 3 matrices. 1, 2, 3, 4 times 1, 2, 3, 4, that gets me 16. Okay, so the steps are simple. It's just that you should never forget to add the alternate signs between the positive and negative signs in between the matrices. Okay, so this will be my explained, simplified and more detailed working. Okay, so this will be for my first row, first matrices. Okay, so I'll only pick one row and one column. So let's say I take the first row and column. So I will multiply it by the minors, which is 1, 4, 3, 2. Okay,
minus 2, which is this one, the second column in the first row. And what I did here was that I actually timed them with 3, 4, 3, 2. So whatever number or column that I pick, the column and the row that I pick is not going to be available for the AD minus BC step. So if I were to pick the third column in the first row, which is 3, so automatically the first row and the third column will not be included in the AD minus BC step. So it will be only the first column, second row, third row, and second column, second row, third row. So this applies to all 16 matrices. And when I did this, remember that this 4 minus, what I did was AD minus BC, hence you get 2 minus 12 because 1 times 2 minus 4 times 3. 2 minus 12. So I did the calculations all for you. So you will get all these numbers. Okay, note that all these numbers are actually our new matrices, our new cofactor. So this is the new cofactor that I had rearranged. So what I did here was that I just simply copy it down, okay, and transfer the data, and I transpose it. What I mean by transpose is that I actually substituted between the rows and the columns. So between rows, I changed it to columns. So 0, 8, negative 4, negative 4, it became one column instead of one row. And same goes to my second row. My second row actually became my second column, and my third row became my third column, and my fourth row became my fourth column. So this transposed version is important for me to divide by my determinant. So as you can see the formula here, so K3 inverse is actually the adjoint, which we did just now, the transpose, over the determinant. Okay, so just simply plug in the data here. Okay, remember that our determinant that we found in our step 1 just now is actually 20. So plug it in and simplify it. So this will be the simplified version of my inverse K3. So that is all for me.
I'll explain the product between matrix P and the inverse of K3. So to get the product, the result from the product, we will multiply the first row of P, this is P, and the first column of inverse K3, and we'll get the first row of the resulting in product. So this the process will be repeated where the second row of P will be multiplied by the first row of inverse K3, the second row of inverse K3, the third row, and the fourth row, and so on, to get the rest of the answers. Okay, then we will get the answer here, which is this is the product of the multiplication, and we will substitute it from the table right here, which is 0 is equal to is A, 18 is S, 15 is P, 4 is O, 4 is EE, and 17 is R right here, 26 is, there's a space there, 7 is H, 4 is again E, 0 is A, 3 is D, 26 is again a space, 18 is S, 19 is T, 0 is A, 17 is R, and 19 is T.
Then we will get the answer right here, which spells out as per Head Start.